three-dimensional object?
You can see all the angles.
It has
all
a
sides.
It has a volume. It has dimensions.
It has volume.
It exists.
It exists.
Wow.
It
So
has
that
to.
folder doesn't exist?
That's 3D.
Okay, makes sense.
A folder is 3D?
Yeah.
No, he just said it wasn't, it's flat.
Okay, but it's not like a flat.
Alright.
I know what you mean.
So,
Yeah, it's not. It's
if
not
you
a
read
square
up
on
here,
paper.
this is a solid with flat sides. Enclosing space. So what's the easiest way to, I guess, what's an easy example of
Sphere.
a box?
Sphere.
A sphere could be.
There's a-
But is a sphere, so here's a great question. We would consider these three-dimensional objects that we're talking about right here something called a polyhedron. So a polyhedron would basically have to involve what? Polygons, right? So here's my question to Mr. Rulin. Is a sphere necessarily a polyhedron?
Because we know flat sides.
Because why? Say it.
Doesn't have flat sides.
It doesn't have flat sides. So is a sphere really a polyhedron with three dimensionals? No. But it could still have space in it, right? So it could still have volume. So he's right that it's going to fit in this category or in this chapter, but it's not necessarily a
What
polyhedron.
about a cylinder?
A cylinder, okay, is it a polyhedron? Not necessarily. But we can still find, when we say flat sides, though, we're saying that
Well,
it-
there is two of them, but how it connects.
Right, how it connects on the inside, the middle. Okay, so, my flat sides, so this is a bunch of vocabulary again. The flat sides are called faces. The faces are going to be some kind of shape. There's going to be two parallel faces. And these parallel, what do we mean by parallel?
They don't Never intersect.
They don't intersect, right? So when we talk about a parallel faces, we're talking about the ends, right? So we get a box, right? We get a box of Kleenexes, okay? So the two sides that are parallel to each other are the side that I'm holding and the top. But it could also be these two sides.
Wow.
It could also be these two sides. Okay? So, here's the question. Two parallel faces are called the bases. So how do you tell or differentiate between a face and a base? Well, on a box, can I realistically tell the difference between the faces and the bases? No.
No.
Basically, if I was figuring this out, I'm always going to think that the base is where? That it sits on, right? But essentially, maybe Tesla looks at it and says, well, I think the bases of this are the two outside ones because it's kind of holding it together. And that's okay too. Okay? And then Naya's going to look at it and say, well, I think it's the front and the back. Right? So, even though that it's sitting on this where it's on my hand, a lot of us consider that being the base. But you can realistically pick any two sides as long as they're parallel to each other for the bases. Make sense? Okay?
Can we do the same for the faces then too?
So, what?
Can we do the same for the faces then too?
No. So let's try to draw this box right here. Everybody know how to draw these? Draw a square right in front of you. Now draw a square back here behind it. Okay? Now connect vertices. Okay? Now, why would I do this?
Because you can't see it.
Because I can't see it. But we know it's there, right? Okay? So, whenever something's behind, we're going to make it a dash line. Alright, so, where are my bases? Okay? So Mr. Rulin's going to say this is a base, and this is a base. That's fine. Everything else then is a face. Okay? Where my faces meet, right here, right? We're going to call these what? All the sides we would call what?
Edges.
Edges. So edges we would explain as what?
Where the faces meet.
Where faces meet. Perfect. And then, Mr. Kroll, all of my edges come together at a vertex or vertices, right? When we say vertices, we're just saying plural, right? Vertexes, right? So my vertices, how can we describe them? Where edges meet. So realistically, where this happens, then it doesn't really matter what kind of a shape it is. But we would call this shape a what? A prism. Okay? So we're going to first just call it a prism, and then we'll get more complex, right? So a prism is basically what we just described over here. It's got to have two parallel bases. The base is a shape, and that shape is how you name it. So, when we get back to a box or a rectangular prism, we could have three different ways of getting to the answer, but we could all still be the same. Would you agree with that? But if my bases are hexagons, for instance, okay? So imagine that this is a hexagon. So where else does a hexagon have to be? The other side over here, right? Because they have to be parallel to each other. And if my hexagons are in a prism, the hexagon is the base no matter how it's sitting. So even if it's in this direct shape like this, but where my hands are hexagons, then this is a hexagonal prism. So what would we say about all of the faces?
Rectangles.
So in a prism, the basis is some shape, and that's how you name it. But all the faces are always, what did we say? Rectangles. That's why a rectangular prism is kind of confusing. But if it's a hexagonal prism, there's no confusion because these two sides are hexagons, or these two sides are these two, and that's where the bases are. Everything else is going to be a rectangle.
Hexagon 7 sides.
Hexagon is still 6.
That's 7.
Hepta. Okay?
So
So we have our parallel faces, we have everything else is exactly the same. Okay? So we'll get into volumes and everything tomorrow.
what's around?
Well, we are. Okay? What?
What's 9?
9.
9 again.
And then realistically, we would hope that we can work with regular polygons, or sorry, regular prisms. What's this mean to us? A cube's an example, right? Because then all of my sides, or sorry, all my faces and bases are exactly the same.
For all the sides to be the same, like for it to be regular, doesn't everything have to be the same?
Well, okay, so this is our question. What do we mean by a regular prism?
All the markings.
What has to be?
Edges.
All the edges?
Vertices.
All the faces, bases, edges.
All the what?
Faces.
Everything.
All
Faces.
everything.
All sides.
I want everything.
What does it say up here?
In a prism, they're all parallel.
Lateral faces.
A regular prism has bases with regular polygons. So what has to be regular?
The side.
Polygon.
Or the bases.
The bases. So in a regular prism, the bases are regular. So, do my edges have to all be the same?
No.
No, right? Because my edges in between wouldn't necessarily be the same length as my edges of my hexagon. So when we say a regular prism, we're only talking about the ends, wherever those ends are. Okay? So the bases are regular. The rectangles in between, we don't care how long they are, how short they are compared to everything else. That make sense?
So they're congruent, right?
What are?
Nice long.
The bases have to always be congruent, but if it's a regular base, then they're exactly the same. Okay? Meaning all of the sides are the same. So you could have a triangular prism that isn't necessarily regular.
So it just has to be a 3D prism.
3D prism. Yes. Okay. Go ahead, Gabriel. Inspire us all, please. You're confused on what?
So the bases are congruent.
The bases are always congruent.
Well, in a regular prism, everything.
No. And the bases are always congruent.
Yeah.
So think of a shape, a pentagonal prism. Okay? So try to draw a pentagon right here. That's a pentagon, right?
It's a stop.
So if I draw another house back here, okay? And then I connect them. Ooh, this one's confusing.
Right to right.
And then draw this one high. Okay? Would you say that this is a pentagonal prism?
Yeah.
Okay? Would you say it's a regular pentagon? Is this a regular pentagon? No. So that's the difference. This is a pentagonal prism. These two are still congruent to each other. They're exactly the same to each other. But in a regular, then all the sides are exactly the same in each other.
And by sides, you mean like the roof and
Yes.
the roof.
The roof.
The roof.
Yes.
Think about shit.
Okay? So if it's a regular prism, the end sides that are a different shape than a rectangle are exactly the same. So if it's a regular rectangular prism, what do my ends have to be?
Say it again.
If it's a regular rectangular prism,
I have 180.
my bases have to be what? My bases have to be what shape?
Square.
Rectangle.
Square. It has to be a square. If it's a rectangular prism, that's a regular rectangular prism, my bases have to be squares. Because that's the only rectangle that's a perfect on every side. Make sense? Okay? So, then we get into a pyramid.
Oh.
So what's the difference between a pyramid and a prism?
It doesn't have
It doesn't have any base.
There's no rectangle.
multiple different shapes.
It has the same amount of sides, but only one base.
It doesn't have triangles.
Because there's no parallel.
Hey, meat sack. You still think a folder isn't 3D? No.
Folder?
It holds paper, therefore it holds.
Alright, so here's my rectangular prism,
So it's
right?
3D.
Otherwise, we'd call this a what?
Cube.
A cube, and it's dirty because we had water in it. We'll put water in it in a little bit, okay? Or tomorrow,
Huh?
okay? So this is a what? This is a rectangular prism. What's this?
Triangle.
Why is it a prism?
Because there's two
Because it's 3D, but it has what?
triangles.
Two bases, right? And the bases, see how they're across from each other? And the triangles are across from each other. Okay? So, here's the question. Would you consider this a regular triangular prism?
No.
I don't know.
No.
Would you say that this triangle right here is an what?
Equilateral.
Equilateral triangle?
Yeah.
So, if this is an equilateral triangle, this has to be an equilateral
So what's
triangle.
the bottom?
What do you mean the
What's
bottom?
the bottom?
It's a
It's a
face.
face.
So, this isn't a base now.
That's
Remember now, if this is a different shape, if there's a different shape besides a rectangle, that different shape has to be the base. So even if I put it down like this, my base are the triangles. Okay? Because it's a different shape. So a lot of times, yes, you would like it to see it like this. Now it looks like the triangle's the base, right? Because look at in the middle. So to me, when we talk about faces, you'll hear me say it's like the guts. It's the guts of the shape. Right? The top and the bottom have to be the same shape, which they are, or this way. Okay? So these are both prisms, right? So what's the difference between this and a pyramid?
Pyramid only has one base.
Only has one base.
But it doesn't have another.
It doesn't have a triangle.
No problem.
What?
It doesn't have a triangle. It's just
It
like-
doesn't have a triangle.
Yes, it does.
There's a triangle.
Oh, I thought you were talking about that.
There's multiple.
So is this a pyramid?
Yeah.
Yeah. No, because it only has 3 sides.
It only has 3
No,
sides.
it's 4.
What about this
Four
one?
sides, but it's
What
not
about the bottom
sides.
sides?
It's not like a bottom.
This isn't a
It
bottom?
should be 4 on the top and then it's sitting on one flat side.
What?
Why does it have to have
It's
4
a
sides?
square involved in
It
it.
doesn't have to.
Why do you need a square?
You can have a circle at the bottom.
Can't I sit this right here on his head?
Look at that.
It's got a base. There's my 4-sided shape. So this is a prism, but this isn't.
Yes.
Because why?
Because the other one has a square base. It has.
Doesn't mean anything.
at the top.
So you don't like this?
Yes.
Or you like this one?
We want-
But you don't like this one?
No.
Because why again?
They're all
Because
triangles?
the bottom is a square.
It doesn't have to be.
So
You can't
every
have-
single pyramid, okay? Every single pyramid has to have a square on the bottom?
No.
No, it can have a rectangle.
Which one's?
Okay, so I can't put, okay, I can't put a pentagon on the bottom?
Nope. That's
To make a pyramid.
4-sided.
You can put a circle on the bottom.
Is it?
That's a cone.
You can put a circle on the bottom? Okay.
That's a cone.
Think about that, hold that thought. Okay, so how many people agree with Riley? There's gotta be a rectangle or a square on the bottom. I can't have any other shape there.
I don't know.
No.
No, that's
So, what do you call this then?
That's a.
Triangular prism.
Yeah.
Oh, wait, whoa.
No.
You just voted with him and said that this can't be a prism because it doesn't have a square on the bottom.
Yeah.
But then he just said, well, that's a triangular
Oh.
prism. Or pyramid. This is a triangular pyramid.
Is it?
Oh, I say prism. I would say
Is it?
Oh.
It can't be a prism.
I'm so confused.
Right. This can't be a prism because it doesn't have 2 bases that are parallel to each other.
So it's a pyramid.
Right? So it's a pyramid.
Yeah.
Are you sure?
Yes.
Or is this one only a pyramid?
Yes.
That's not a prism.
Are they not?
So let's go.
Are they not?
You're actually thinking that's what we want. A pyramid is.
A prism.
Yeah, we
No, pyramid's not a prism. A pyramid
No,
has
What about like ziggurat?
only one base. And that base is any shape.
I was right.
So, is Mr. Kroll correct?
No.
No, we'd love to prove Mr. Kroll wrong. There's only one person better to prove wrong. And that means I get ice cream usually. So it only has one base, it can be any shape. Again, this base is how you name it. So, can I have an octagonal pyramid?
Yes.
Absolutely. I can have an octagonal pyramid. I can have a pentagonal pyramid. Okay? We're just used to, when you think of the pyramids in the desert, right, there's a square base, or at least a rectangular base. But it doesn't have to be. Okay, so, all the faces are what?
Triangles.
Say it again, bud.
Triangles.
All the faces now are triangles. And meet at one point. Right? So here's my shape again. All of my triangles come and meet up at this one spot, way up here. Right? Triangle, 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 triangle. So here's the question. Are all my triangles always the same shape?
Yes. Yes.
Yes.
Otherwise it wouldn't be that
Like,
long.
It wouldn't be a balance.
Like the same
It
shape.
has to be a perfect
Yeah.
base.
So, what do you say about your base then?
It has to be
gotta be
perfect.
right.
The sides have
It's gotta be a regular polygon? We
And
can't
then
do it any other way?
Because we can't, unless you smile.
I'm just asking.
No, you can't smile
Okay.
and go back on it.
So, here's the difference with a pyramid also. A pyramid is going to include a slant height. I just want you to be introduced to that term before we throw it out at you again. Okay? So these are the two complicated ones in a sense, right? Because my bases can change all the time. What you got to differentiate is a prism is always going to have a bunch of rectangles. Now the ends might not be rectangles, but that's where this gets a little confusing because when you do this problem on a quiz or a test, Tessa can do it one way, Nye can do it another way, and Brandon can do it another way, but get the exact same answer for some problems, meaning the surface area, right? No matter who sees what as their base, the surface area is still the same, or the volume is, right? The inside is not going to change. Everybody cool with that? Okay? If it's a pentagonal prism, this is a pentagon, this has to be a pentagon. Okay? Even if it's sitting just like this, these are still my bases. But then it's really obvious what my bases are. So you're always looking at, in this, it's hard to tell because they're all rectangles. In a pentagonal one, you know that the houses, which are my pentagons, would be my bases. Okay? A pyramid always has a bunch of triangles. So the one that Mr. Kroll didn't like was this one, right? Where the base was actually a triangle also. Okay? But
Agree with me.
So I figured maybe, hey, let's just go with it.
hey, we made you think for a second.
It's one of
So the next one then, let's go back here and put the next vocabulary word right underneath this. And let's call the next one a cylinder.
How many more do we have?
What's a cylinder?
Circle
Top man.
as the base.
Two circles.
Two circles.
It connects to each other.
It connects to each other.
And it's
Two
the
because it's a base.
So,
And it
round.
continues-
is it a prism?
There's
Round.
three. Yes.
Kind of, it's not, but
It's the same like
it
concept.
kind of fakes it, right?
Well, it has
So-
parallel bases.
In a cylinder, we would say a solid.
It's like a top.
So it's got to be a solid though still, right? With, well, that's ugly. Congruent bases that are always what?
Circles.
Perfect. And again, my bases are parallel. So realistically, it's not a prism, but it has a lot of characteristics of a prism, right? Okay? And my circle is always going to be on it. So it's not a polyhedron because of the circular base. So what's a cone?
Where it's a circle and meets a point.
Okay, so a cone, we come back over here and put a cone underneath a pyramid because a cone realistically is
Pyramid without.
a pyramid, but always has a what? Always has a circle for the base. Okay?
Well, you just say it has no edges.
You can say whatever you want, buddy. Okay? And then this has a vertex. Only one vertex. Mr. Kroll, turn around and find us a cone. Right above you, right above you. So we got a cone, right? So my cone looks exactly like our, thank you, sir, our pyramid that we just had, right? Okay? But it has a circular base every single time. Only one vertex. That one vertex is right here. So again, we're going to also have a what? A slant height. So if you want to write that down there too, well, we will have a slant height in a cone.
How many equations
Remember how many there were last time?
Yeah.
Probably more. And then last but not least, what Mr. Rulin came up with was a sphere. So what's a sphere?
It's
Oh, this is where we had our,
oval. It's an oval.
right? It's an oval, right?
Yeah.
So-
It's a football.
It's an egg.
A set
It's an egg.
of points.
See, we've already proved this. It's not.
This is not a football because of this right here, buddy. A set of points in space.
Since when is there a point in a sphere?
So you're saying the Earth is an egg?
No, the Earth is.
That are a given distance from the center.
Are we talking about space? In science?
Hey, buddy, if you think about a basketball,
Yeah.
you didn't like my samurai sword thing, but what is the space inside of a basketball?
Air.
Air, right? So there's some little dot in the very middle of that space that to the outside of my ball is the exact same distance.
That's called a second.
Okay?
Why does it have to be a dot?
What would you call an object that has no faces? Like a three-dimensional object with no faces.
No face is impossible.
Did you just say why does it have to be a dot?
Yeah.
Like an egg. What would be the geometrical term for an egg?
An egg.
Oval. Like an oval.
Or an ellipse.
There you go.
Oh,
Is that a square egg? That's what an egg is.
Alright, the last thing that they talk about here are two things. If you're into polyhedra that are called platonic solids, Mr. Kroll would like this. On page 577, these are shapes that have the exact same shape for every single side. So if you want to look those up, just look at them real quick. Okay? The last thing they talk about are cross sections. And this is the last thing we're running out of time here.
I think you're going crazy.
Oh, that might have been in the old book.
So, are we
Where's the book
How are we supposed to do our homework?
Today there's really not a whole lot of homework.
I was gonna say, he literally just covered everything.
They've probably just been naming them.
Today's just basically identifying sides and
Because
stuff.
he went from 12,
So
to
turn your
12,
book to
6, now we're-
page. Oh, this book doesn't have it.
Yeah, we were from
8:30.
Wait, turn to page what?
This book doesn't have the platonic solids. If I find it in an old book, I'll show you it tomorrow. Okay. The last thing we want to talk about are cross sections, though. So this is in a plane when you have parallel bases, and so again, if I have this rectangular prism right here, and Gabriel gets a samurai sword out again, and I hold it right here, and he chops in between my hands, right? And then I pull it apart like this, what are you always going to see?
The base.
the base.
Whatever the base is, right? As long as I hold it on the basis. So if I would open it up and my hands were on pentagons, then if I open it up after he cut it in half, every single, or the sides that you would see would be called what? Or would still be the pentagon or whatever shape it is. If I had a sphere and I held it and then he cut it down right down the middle and I opened it up, you would still look at two what? Circles. We would look at two circles. And in a sphere, that circle that you're looking at, which would be right down what I would call the middle or the equator in a sense, right? It would have to be what circle of that sphere? It would be the biggest circle that would be a part of that sphere. Because as close as it, when I open it up like this and I'm holding that ball, I'm palming the ball, right? You're looking at circles. But if he starts slicing pieces off, every time he slices one is always a circle. But the biggest circle that we had was at the very beginning when we cut it right in half. When it gets to my hand, it's going to be a really, really small circle. That makes sense? So that's what they mean by cross sections. And again, this is more just, to me, it's like slicing it down the middle. But you gotta hold on to the bases. Okay? If you don't hold on to the bases, like you have a pentagonal prism that we had up here, and you don't hold on to the bases and try to do this, then it's not going to show pentagons, right? It would show a bunch of rectangles when you did it the other way. Okay? So that's the only thing that they're really trying to show in that section right there. So again, I apologize for talking about that platonic solids. They're actually kind of cool, and I'll try to find it in the other book. So realistically, if you want to do the homework for today, there's only 8 questions. We're not going to have an understanding tomorrow over this. So this would just take you through trying to find faces and bases of a shape and that kind of thing. So if you want to look at those, this is just basically for an introduction. All right? So realistically now, going forward, we're going to break these down and do surface area, lateral area, and volume of each one of those shapes. And that's where it gets a little complicated. Okay? So there is going to be a lot of formulas again. Alright, so I would find a way to kind of copy those down and start studying them day by day.